Hi friends, let's have a look at problem 3255. Find the power of k-sets subarrays 2. So there's another earlier problem which is the same title but with 1. So here we are going to solve these two problems together here. So we are given an array of integers called nums of length n and a positive integer k. So we have a definition that is the power of an array. So it's defined like this. Its maximum element if all of its elements are consecutive and sorted in ascending order, otherwise -1. So we need to find the power of all subarrays of nums of size k, right? So notice that if you have an array of length n, then the number of subarrays of size k is nothing but n minus k plus 1, right? So here is the return. So we return an integer array of results. So this, because this is the number of such a length k subarrays. So you have n minus k plus 1 length of this result, right? So here result I is the power of the subarray. So starting from the index I and ending at index I plus k minus 1. In other words, it's a length k subarray, right? So here, if you look at the first example, so here k is 3. So in other words, we consider length 3. So here we have 1, 2, 3. So the power is 3. Then we do sliding window. We have 2, 3, 4. So this will have power 4. And then if you look at 3, 4, 3, and this because it's not ascending and consecutive, so it's -1. Similarly, 3, 4, 2 and 3, 2, 5, they're all -1s. So we get this return. So the example 2 is very special because all the numbers are equal. So we have all -1s because the length here is 5 and k is 4. So 5 minus 4 plus 1, that is 2. So the result will be length 2. So we have two -1s here. So here, if you look at this one, the k is 2. So then we see that here we have 3, 2, and then we have 2, 3, and then 3, 2, and 2, 3. So those two are alternating. So we have -1 and 3 alternating. Notice that the length is 6, right? K is 2. So 6 minus 2 plus 1, that is 5. So we have 5 in length. But the first one is decreasing. So we have -1. Beginning with -1 and alternating with 3. So this is the result. And the constraints are the following. So the length is bounded below by 1 and bounded above by 10 to the power 5. Because of this number 10 to the power 5, we need to consider time complexity, right? So the numbers are positive and the k is in between 1 and n. This is for consistency, right? So in this problem, we are going to provide two versions of solutions. So here I'm going to first explain the DP solution. So the DP solution will have time complexity O of n, where n is the length of the original array, right? So and the space complexity is also O of n. Then I'm going to improve the DP solution to be a for loop solution. So in which the time complexity will be On and the space complexity will be optimized to O1. In other words, constant time space complexity. So as I said here, these two solutions to be presented are essentially the same. So here I can start with the DP solution and then I'm going to explain this key observation. So once you see the first solution, then the second solution will be rather straightforward. So we can regard it as a translation. So let me make some annotation. So this version is DP based, dynamic programming. So for this purpose, let me first introduce this n. N is the length of this array. So here I'm going to introduce a DP, so which has length n. So starting with all ones. So here you can interpret this DPI to be the longest consecutive. So consecutive mean incremented by 1, right? Segment or subarray size ending at I. So in other words, inclusive, right? So in other words, we want to first get for each index I the longest consecutive segment ending at the index. So we get all those size, right? Longest such subarray size ending at I. So once we get this, for each index, we just need to compare if the length is greater than or equal to k, right? Then we can get the power. So if it were greater than or equal to k, then the power will be just nums at that index. Otherwise, it's -1, right? Then let's do this. Fill this table. This is very straightforward. So for I in range 1 to n, because the first item, there's no previous element, so it's no comparisons. Then we start from index 1, so we can compare with the previous one, right? So if nums I minus nums I minus 1, so it's 1. In other words, this is indeed an increment by 1. Then the length or the size of such sequence ending at 1. So it will be something like this. So dpi will be dp I minus 1. It's incremented by 1. So notice that dpi is at least 1, right? So this one is always greater than or equal to 1. In other words, greater than or equal to the original value we set, right? Otherwise, we don't need to do anything. We just set the dpi to be 1. So, but we initialized as 1. So this would be 8, right? And then we are going to prepare the return. So this will be also easy. So let's initialize a result like this. So I'm going to use append operation. So this way, if we avoid tracking the indices, right? So we need to start from index k minus 1, because the first length k subarray will have an ending index k minus 1, right? So starting from index 0, then we use sliding window, right? Something like this. But here we don't need to explicitly using a sliding window. We just need to compare the dpi and the k, right? So for I in range k minus 1 up to n, right? So how many elements from here, k minus 1 to n? This is the difference, right? Because n is not included, minus 1 minus k plus 1. So what we want to do is if dpi is greater than or equal to k. In other words, there will be at least one length k consecutive incrementing subarray ending at that index. So the power will be nothing but that number, so nums I. Otherwise, things will be easy. So we get just append -1. So this will be 8, right? So we can return the result. So actually, this is a resolution of one resolution of this problem. So rather straightforward if you digest the logic. So now let's do a test first. Yeah, it passes the first example. Now let's look at the generic case. It passes all the cases. So now let's look at the time complexity, right? So for sure it's t is O of n because we just use 2 for loops. And then the space complexity is O of n also. The reason is due to here, right? And also I don't really, if we count the result, it's also bounded by n. So overall it's O of n. So we want to improve that to be O1. So now let's look at this observation. So actually, when I do the problem, I first do this another version, the version I'm going to present next, and then we improved to a DP solution. But here in this presentation, I reversed the order. So in order to do the second one, you need to do this observation. That is on the length of a consecutive segment. So for an index, if we have this relation, then the consecutive segment length is incremented by 1. right? Otherwise, the consecutive segment length ending at index I is reset to be 1. So this is actually exactly the way we set the DP table if you interpret using DP, right? Then for an index, if the consecutive segment length ending at I is greater than or equal to k, this contributes to nums I to the result. That is the power. Otherwise, it's -1. So this actually, if you were given this code, this will be very easy to interpret it. But if we write in the other order, that things might be slightly different. But here, let me first present the code, and then we make a comment on the sorting process. So what we want to do, so here this version, is a for loop. So I'm using a for loop. You can use a while loop, the same thing, right? So what we want to do, let's first get the length of this nums, same as above. So essentially we are doing the same thing as above, but we just do it during the for loop. And first I want to treat a special case. So that is k when k equals 1. So if k equals 1, so we just need to consider length 1 subsequences. We just need to return the nums itself, right? We just return nums. So now let's look at the general case. So for general case, so we can define a running variables called, let's call it consecutive length. So first I'm going to get this result, so to hold the return, and then we start from left index 0, and then the consecutive length is 1. It's corresponding to a array length 1 at index 0, right? And then I want to do a for loop for r in range, so 1 to n. So this to me is like a 2 pointers method, but it depends on how you interpret the code, right? Then I'm going to first update the variable consecutive length. So this consecutive length actually gives us or denotes the longest consecutive increment subarray size ending at r, right? So let's do the check. If nums r minus 1 equal to 1, then this consecutive length will be incremented by 1, right? Otherwise, so because it's not this relation, then the consecutive length will be reset to be 1, right? Then we get this one. So when r equals k minus 1, so if you count from 0 to k minus 1, this is the first length k subarray. Then we can start to add those two results, right? So now let's do the check. Check if consecutive length is greater than or equal to k. If this is the case, I'm going to add them. So we need to start from k minus 1, because if it's a length from 0 to this number is k. If this is less than this k, it's impossible for consecutive length to be greater than or equal to k, right? So then if consecutive length is greater than or equal to k, right? So in other words, we don't need this if condition, because if r is less than k minus 1, it's impossible for this number to be greater than or equal to k. But in order to make the logic clear, let's think add this if check, right? So if this is the case, so we are going to append the result with the current nums r, right? Otherwise, so we append the result with -1. Then we just need to return the result. So if you look at here, this one, when r is greater than or equal to k minus 1, so this is nothing but here, right? So from I This you can interpret as I as R, right? So this way, so here we are using a running variable to replace this DP table. So now because I have changed the function signature, so let's do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So here, let me make a comment. So when I do the problem, actually, I first did it in this way, right? So actually, this is not a two pointers method, but because the way we write it like this, L and R, I always write this style or pattern when we do two pointer sliding window method. So then I inspect this code. Actually, this is nothing but DP, right? So in other words, for each index, I want to compute the longest possible consecutive increasing subarray, any at the length at any at that index. Then I just need to compare the length with the k. If it's no less than k, so we are going to get a power corresponding to that element in the array. Otherwise, it's -1. So this is exactly here. So technically, if you interpret like this way, writing code in this format is much easier, right? But writing this one is a little bit challenging than this one. But both are, sort of typical codes. So with this comment, I guess that's about it for the current problem. Yeah. Thank you.